further ado, Lars, welcome to the session.
Thank you. I will try to find the button for sharing screen, and I will share my screen momentarily. There it is.
Okay.
So to give some context on the startup problems here, we prepared everything on the other computer, then it fell off the network. So that's why you don't have a camera feed for me right now. It's in the other end of the room. And that's unfortunate, but that's what we're dealing with. And we might not be able to do my second demo. Maybe after we're partway through this talk, maybe I just run over to the other computer and see if things have improved. We'll try it. We'll experiment a little bit, but definitely some last minute crashing. So that was fun. All right. Thank you for the lovely introduction. As mentioned, I'm Lars Wikman, and this talk is about tracing. Now, maybe some of you have done OpenTelemetry and worked with like OpenTelemetry traces. That's not what we're talking about. This is about Erlang tracing. Now, I'm curious, and this can be tricky in a Zoom call to capture, but has anyone used tracing with Erlang? You can do like the Zoom reactions, raise hands, or any of that. Or type in the chat for all I care. Any of you have used the Erlang tracing facilities? Video has not. No. I see at least 2 negatives, which is also a good response. Yeah. Brief interlude before we get into it. I'm Lars Wikman. I run underjord.io. There's a blog, there's a newsletter, there are several podcasts, there are videos on YouTube, and there's a bunch of open source projects. Moving on. So this is not about telemetry or like that type of tracing. The Beam and Erlang allows us to do runtime introspection of almost everything about the system. And when I'm saying runtime, I mean as opposed to something that you define up front. So with telemetry, you define your spans and you get like information about important parts of your application, and you can keep statistics and all of that. But Erlang tracing is something quite different. It is meant to give you the ability to ask your system to report to you while it is running without essentially changing the system. So it uses these nice abstractions of our runtime to achieve this, and it is very flexible, incredibly capable, and to my knowledge, most Elixir developers don't know about it or haven't used it, or when they would have had a need for it, it's kind of complicated to get started with if you haven't installed the right libraries and all that. But it will let you look into like which functions are slow, why are they slow, what is a function being called with, what arguments is it being called with, what are the return values, and much, much more. So the Erlang standard library gives us everything we need in this obvious and simple API. And when I'm saying obvious and simple, I mean the opposite. This is a little bit involved. So the first thing you do is that you call Erlang trace. It's in the Erlang module. So right in the middle of our Erlang, it's a trace function. Okay, fair enough. All. So this means all existing processes and any that will be created after. You could also pass in new if you only wanted new processes to be traced. True is an argument here because we want to trace. We don't want to turn off tracing. So that's what that does. And in this case, we send some options. In this case, we want to trace function calls. There's a ton of things you can trace, but function calls is very useful. We want some timestamps with those. And we want it all sent to a tracer that is, in this case, the current process the PID of self. So this is perhaps not what I consider the most obvious API, but this is only half of it. The next step is to call trace pattern and give it a module function and array tuple. I like, and these are called MFAs if you haven't run into them. And I like MFAs. They are a pretty good way of specifying module function and arguments. Actually, if you have any questions, type them in this chat at any point. I will try to keep an eye on it, and I'm also happy to take a break and try to expand on something or explain something. It's fine to actually just pipe up during the conversation. I will try to hear it. But yeah, this is a way to specify a module function and an arity that you want to trace on, and you can replace any part of this, or there are some rules, but you can replace parts of this with an underscore atom instead as a wildcard. And then we have this. Anyone here who worked with match specs? Can I get some reactions to mark whether anyone has done a match spec in their Elixir work? Again, at least one no. Match specs are how you do queries in ETS and Amnesia. It's fairly unusual that you need to get very involved with match specs, but they're powerful. They're also super weird, and I can never learn them. But they are useful and they fulfill a purpose here. Message and caller and exception trace, these all say something about what information the trace can get us. And then we have this local option, which does not mean trace on the local node. No, it means that if we set global, it would only hit functions that are calling across to other modules, while if we're saying local, it means also trace within module function calls that are within a module. There are more options that we will not be covering. So if you do this, you start to get these messages, assuming there's something calling the function you're tracing. So if you're tracing the Erlang module Q for the function new at arity 0 with the options I provided previously, you would get messages like this in your IEX prompt or wherever you're doing the trace. So you get a message on the call and your message on the return, which is not bad. That's a lot of good information. And you get the PID of the process where it happened. You get module functions and either arguments. So you get the arguments. Here we can see an empty list. That's the arguments. That's an MFA with arguments. This is an MFA with arity, so the number of arguments. So we get this for the call and this from the return from. Now this here, that's the return value of the function. There's also timestamps. These numbers are Erlang timestamps. Also kind of confusing timestamps, but they're definitely usable. And if you care about API design, you might ask, why are there two functions and why are match specs involved? This all seems kind of complicated. And I think the reason is to separate the necessary upfront config from things that you might want to do per pattern. So you can set multiple trace patterns and treat them kind of differently using match specs, but it's honestly, for my taste, too complicated. But it allows tracing in one way until a certain match spec is hit, and then you can trigger a change so that the tracing will kind of react to things happening in your system. So it's very, very capable, super powerful primitives, and someone really needs to build something simpler on top of it, because I find it really hard to use in the default way. So there are higher level abstractions for Erlang tracing, because no one can remember how to write match specs. Erlang ships with DBG, and it's called the text-based trace facility. And you can start the default tracer like this. So this is calling Erlang from Elixir. And you can say that you want to trace for exceptions, which will also give you returns, I believe, by including an X. So they do module, and then they do function atom, and then they do options, essentially. And it's nice terse naming. And then it tries to make match specs fun, I assume. This is an abstraction for making it easier to write the match specs. I had problems with it, trying to make that work under Elixir. I don't know why. It might be using something Erlang specific. So my challenges with this one is that I had problems with it under Elixir, for one thing. And then also it's using very short, terse function names, which is cool if you want to seem like a cool hacker, but not necessarily the easiest to remember. When something is broken in production, you're trying to figure out why, or something is slow and trying to figure out why. It might not be all that helpful for you to remember that you need to write .tp to call it. It's definitely simpler and friendlier than the Erlang primitives, so it's getting that right. It still wants you to use match specs for a lot of stuff. I'm not convinced by that design choice. And there are some ways to put safeties in place so it doesn't overload the system. It might have them by default, but I didn't fully find information on this. When I gave this talk in Stockholm recently, some of the Erlang folks there indicated that there might be a mechanism for that. Yeah, it's an okay library. I'm sure it's helpful. I don't love it. So Redbug, this is more of a well-respected one. It's an Erlang, it calls itself an Erlang tracing debugger. And it has this Redbug start and then a string q new. So you're essentially writing Erlang code as a string. You can stop the trace. You can say, oh, I want return values as well, or return values in a stack trace. So this is kind of convenient. It's much more convenient than DBG or the base Erlang stuff. And we can just show it actually working, I guess. Let's see this one. So here, can everybody see the editor? Okay. Might be a bit small.
Yeah, we can.
A little bit larger. So if I want to do a face for QNU, that will, so this is a very silly little Elixir project that will just call QNU and maps get every 2.5 seconds. This is a good way of demoing tracing. So this will trace for a particular amount of time, which is one of the default behaviors of Redbug. So something Redbug does really well is that it protects the user from overloading their system. You can absolutely trigger too many trace messages and overload your system, but Redbug has protections from that. It uses clear function names. It uses simple conventions. It is all about strings, which means no match specs are required, though it is also all about remembering those strings, which I don't find ideal. It is not super discoverable because you don't have autocomplete for finding these strings that you need to write. And the string syntax is written in Erlang. I believe there is an Elixir wrapper for Redbug that does something similar, but with Elixir style code. But overall, Redbug is useful, nice, easy enough to use, but I don't find it kind of idiomatic or ideal. But definitely good, and has been a staple in the Erlang ecosystem for a long time. Then there's Recon. And Recon has a module called Recon Trace, which provides utilities for tracing. And it uses an MFA, which I think is a good way of matching. So that's pretty much how trace pattern works. It requires you to provide a limit to the number of traces, which means it has built-in safety. You will not accidentally trace your entire system and bring it to a halt. And then you do end up needing to write match specs for particular behaviors. Here is an example of using ex2ms, which is a very, very good library if you need to do match specs, which lets you write them as function-like macros. It's called ex2ms. So we can do a brief demo of recon trace as well. It works very similarly to Redbug. Restart this. Some calls here. It's wildcard the arity. About 10 of those. And it will print the message. It will print output about what's being traced. Right? Works very similarly. But this is something you can do when you have a production issue. If you have recon trace or Redbug installed, you can go onto your server and ask these questions and say, I want to see how this function was called, with what arguments and everything. So it has clear function names, it has simple conventions, it uses MFAs, and I like those. It still uses match specs, which I don't love. And the Recon X Elixir oriented wrapper seems to be outdated. It has built-in safeties, which is great. And Recon is in generally just useful. So there are other cool tools in Recon that you should look into. Then there was EDBG, which I didn't know about until someone said, oh, I saw you're talking about tracing. I built this tracing library. This is very much oriented similarly to DBG or similarly to debuggers. So if you're used to working with debuggers, you might like this. I had trouble understanding how I was supposed to use it because I don't really use debugger sessions very much. But it's an interesting option, and the person who made it seemed very friendly. So why am I talking about tracing? And what am I going to do if I have so many opinions on how others have implemented their tracing? I built my own, of course, because that's what you do when you're too enthusiastic about a language. You build things. So we have a trace, which if I just autocomplete here, I see a bunch of different functions. So what I'm going to have to do is trace the start link. To start a gen server, and then trace, and pass in the PID. I give it Q, U, and then I might pass it self. So if I remember my own API, yes, it will start sending me messages. Now we're getting debug logging as well, because I found that useful. But if I flush, I have received messages, and the shape of these messages is relevant. So I'm getting messages with a struct in them. This contains the same information as you're getting from the basic Erlang APIs, but structured. So it's the MFA that it was called with. It is the PID of the process that called. It is when it was called, when it was returned. So that way you can get the full timing. But you're getting them as date timestamps instead of Erlang timestamps. And you're getting the return value or the exception value. In this case, we're also seeing the stack trace. And if you're on a modern version of OTP, you will get that. You will get what line, what caller and what line of which file trigger the call. And you'll get one message per call and return, but they are matched up with IDs, so you can know that this is the same trace getting an update message. It has a safety built in. It will not do more than 200 messages by default. You can pass in other limits like timeouts and stuff. So that is the library I started building for my own tracing needs. So you start it, you set a trace, or you can also pass a function instead of a PID, and that function will be called. Or you can even pass an MFA for which function you want called. Then that will be done for each trace message. So here we have explicit starting of the trace listener. This has a lot of purpose. The idea is that the trace library is the primitives for tracing under Elixir. It is not the most high level API, and we'll get to why I made that choice later. I think the function names are reasonable. It uses MFAs. I've said I like those. And it has a variety of ways in which you can trigger, or you can manage the trace, whether you want it sent to a PID or running a callback function or something else. It has structure, and it provides a lot of information by default. So it includes timestamps, return values, exceptions, callers, and stack trace by default. This is not what other libraries typically do. They do some mix of this, but generally not all of it. As mentioned, it has built-in safeties. And there's also distributed tracing. So there's a function called trace cluster, which will, assuming you've set it up for this purpose, be able to trace across a distributed Elixir application. Now, running StartLink is not a nicer API and keeping track of a PID and all that, but that's to enable this common Elixir pattern. You've seen this for Ecto repos, you've seen it for Phoenix PubSub, you've probably seen it for other additional tools where you define a module that is yours. So in this case, it would be my app.tracer or app.tracer. And it just does use and trace.tracer. But what this gives you is a module with tracing functions in your namespace with a global known name. So you can just put it in your supervision tree, just like your repo, just like your PubSub. And then you can call it anywhere without specifying a PID. So you call app.tracer.trace and pass your MFA or the trace handler. And you can do the same thing across the entire cluster. So if you have app.tracer running on all nodes of your cluster, you can call it on a single node and get traces from the entire cluster, which is nice, or it can be nice. In all my testing, you can't have a ton of tracers active at once. So that's one reason it's useful to have a singleton, much like Ecto optimizes for running a single database data store with the repo pattern. It's annoying to reference the PID. And this is an Elixir convention. So I'm trying to keep to that. The goal is to not be surprising for an Elixir dev to use this and to allow you to auto-complete your way to success. Now, if this is not enough, it supports multiple patterns. So you could trace multiple sets of functions at once. You can modify the safe default message limits. You can also switch it to use primarily a time limit. There is still also a high message limit for this behavior. And you can also pull list trace info, which will pull out call counts, memory, and timings. The information can be kind of weird. I don't fully know how to interpret it yet, but this is information that Erlang can provide based on tracing. And I actually made 2 libraries. So this is where we'll find out if my other computer is back in action. I will try to join from it. But I do believe I actually have a video of this thing. Hold on, just let me find it. So hopefully this is okay to look at. Can you see the video? Just anyone can confirm.
Yeah.
Good.
We can.
I had forgotten I had this video, but that's actually fortunate considering. So this is Phoenix Live Dashboard, if you have seen that before. And this is a new plugin page I made that is just a separate plugin where you can trigger trace patterns for your entire cluster and go request traces, and then you get them as a table. You can essentially just log into your app and say, hey, I want to know what this function is doing. And then you get information as that function is being called across your entire application at runtime without any extra work. You can search it, you can sort it, all of that. So this is probably the real reason I made this library. We can go into that a little bit, because what I want is for people to recognize and realize just how much they can do with the Beam. And many Elixir devs come at this all through Phoenix and the web and doing web development. You don't really spend a lot of time with OTP and Erlang. You don't have any reason to learn tracing. You might not live in the shell. You might not be super comfortable in IEX. So making it accessible, making it easy to find, even without shell access, was part of the goal here. But I don't want to bloat the original library with it. But this uses the ntrace library. I wanted to plug into the default Phoenix tooling. If I can convince the Phoenix team to put it into the default distribution, that would be even cooler, but I have no idea if they will. And I think it's also an interesting demo of Erlang and Elixir and how they are fundamentally different than most ecosystems that you would run into. I also want to call out Orion, which definitely inspired this attempt. So that is also a tool which you can just plug into your Phoenix application, which uses tracing to do distributed profiling. So it's a separate UI from Phoenix Live Dashboard, but it's a very cool project by Thomas DePierre, where he lets you essentially check the performance of particular pieces of your application in a similar way. I focus on the arguments and return values of a call, because I consider this more of a debugging tool, and in his case, it is more a performance monitoring thing or performance debugging. And other people have done other things. So Orion, in turn, was inspired by a tool called Xprof that doesn't really build on modern OTP versions, unfortunately. That's an Erlang tool. And a lot of people have done things to kind of try to visualize the Beam, and some of those use tracing, some do not. These are some examples. So Visualixir seems cool, or Vislixir is the current fork that works. And Erlang PL seem to do something interesting as well. And then there's tracing message passing in Livebook for supervision trees. That functionality is based on message passing, or on tracing messages, which is also something tracing can do. So what could be future avenues for a tool like this? So there's message sending and receiving, because tracing can also follow that. And then there's fine-grained tracing of spawned processes. And I think you could do that with sequential tracing and a few other mechanisms. So there's just an immense amount of power and possibility in the Erlang primitives, but they are kind of tricky to get right. Then there are just things like visualizing the message flow of an application and mapping it out to figure out what is it doing, and is it doing what one would expect. That's something I want to explore. And there's also the question of what you could do automatically. Like if you are frequently getting a web service error, could you trigger a trace to try to drill down for the admin without even doing the manual work of that? Just tracing to see if it happens again, tracing to see what the inputs and outputs were, and or if something times out, can we trace it next time? Or how could we sample problems, and could we automatically kind of dig into them? And one question I like to ask is, like, what are things we could build using the Beam that no one else can? Because I think we have potential that almost no other tool has for what our runtime can do. So essentially, what does a New Relic or a Honeycomb for the Beam look like? Because a lot of tools need to kind of hook into your code or be added to your code to be able to do this, and the Beam just has a lot of tools for it. And that's about the ground I intended to cover. And I'm very happy to answer any questions or show you more of the code or more of the tool if there's any interest in that. Thank you for your time.
That was a great session. Thank you very much, Lars. I'm really sorry for the technical hitches.
So it's
today.
not. It's definitely not on your end. I'm very sorry for everyone who's attending. And yeah, I had prepared the nice camera for you all, but
I know. I saw it. At least we saw the demo. Juliet and I have the upper hand for that one. Yeah. But it was a good session. I enjoyed what you presented. I hope everyone else did too. Do we have anyone who has a question? Please feel free, or a comment or feedback. Please feel free to unmute.
Yeah, there's not a lot of us, so we can just talk.
Yeah. Also, feel free to turn on your videos. We'd like to see your faces. I shouldn't be talking because my video doesn't even work, but still, we'd like to see your faces.
It's dangerous if you're driving like me.
Are you driving and attending a meetup at the same time, Sigurd? That's wild.
It's dangerous.
Always hustling. Okay.
Yeah. Okay, then I guess no questions, no feedback, but I loved the session.
Tell us what a singleton is. That's commented in the question, and also what is tracing and why do we need it? Okay, yeah. So in this case, I'm calling it a singleton because it is a thing in your application that you only really have one of, such as the Ecto repo, or yeah, let's see if I have some example. Yeah, okay, so this project does not work. I didn't get it working enough to demo it, but if you're working with Phoenix, you have my module or my app.repo, generally, my app of telemetry. These are locally registered under a atom name, so there can't really be multiple of them. If you start another one of these, you'll have a naming conflict and it will fail to start because it's addressable by the name sample.repo. And that's practical because it means that you can have a repo module that knows what it will be running, what name it will be running under, and that's what you use to make all your database queries, unless you're doing something specific. So if you're doing things like dynamic repos or dealing with multiple varying database connections, then you will treat repo differently. And in Entrace, I use the same pattern. So the repo module is typically just a use statement for ecto-repo and a specification of which type of database it is. And then that pulls in a bunch of configuration and starts your database connection. So that's the, I just called it singleton pattern. I don't think that that's the official name. Phoenix PubSub does something quite similar, but in this case, it explicitly sets the name, but it's the same idea. Okay, singleton understood. Good. And what tracing is and why we need it. So one example where I've used tracing is when there is a mysterious crash in a web request, or a live view that's restarting, or a channel that's not connecting properly. And the traceback doesn't really tell me why. Sometimes there's just not enough information. There's something in the middle of the process that's failing, and I'm not getting enough information there. If I want to see what that function inside of a controller or inside of a join call in the channel is actually doing, or if it's being called, for example, it might seem like it's being called with some unexpected value such as nil. Maybe you want to see that, or maybe you want to see what it produced. Then you could just jump onto a server, start an IEX prompt, so a remote shell, and run a trace against that. Or if you're using the live dashboard functionality I showed in the video, you could just go into that UI and say, oh, I want to know this function call, when it's being called, how is it being called? What are the inputs? What are the outputs? How long is it taking? And you will just get that information when you're trying to reproduce it as it's being called again, without doing a new deploy with logging or anything. Oh, you missed the live dashboard. Yeah, so there is a live dashboard in this case, but you can also do it from IEX. So in this case, it's fundamentally just a bunch of fields. What module, what function, what arity do you want to trace? And you only really need to add the module, but usually module and function is pretty good. And then you get the results as they happen. So something here asked where the server is. It made a call, it produced outputs. It took very few milliseconds. So this is a tool where you can just go into the web UI and ask questions about your system. And like, Node.js cannot do this. You would have to build an entire system on top of Node to be able to answer half these questions. And I don't know that the people doing Java can do this. I don't know any ecosystem where this is possible to this extent. There might be some, but ours certainly in the lead in these terms. And the people doing Erlang professionally have been doing this forever, because it is a fundamental debugging tool of Erlang. And I think it's underused in Elixir. It's really powerful. I hope that's a decent answer to your question, because it was slightly what the talk was all about. And Trace is probably ready to use. It doesn't do anything too dramatic. It doesn't do anything too dangerous. Currently, I haven't put it on Hex yet because it should have better documentation for a full release. But you can use it as a Git dependency from github.com/lawik/trace. So maybe I'll just type out that URL so it's in the video. Yeah, it's this, and then there's also the live dashboard, which is so those two modules you can get off of GitHub. And yeah, if you don't know, like, you can, in your mix, you can just do github:/trace. I will put them on Hex when I feel they are fully done. And if anyone wants to help, try them out, poke around with them. I have already put the Trace in one of my client projects because it is useful. All right. I think that's where we wrap up the questions.